And so today we're going to be measuring our compression ratio on a Honda Civic engine from my friend's race car, and then we're going to compare it to the Carnot thermal efficiency and then its Otto cycle thermal efficiency. So first we have to go and take that engine and we're going to put it on that mount there, and we're going to measure our compression ratio.
But the feeling is fine. Can't you see, honey, you are for me. Oh, we were meant to be. Dancing in the moonlight, gazing at the stars so bright, holding you until the sunrise, sleeping until the midnight. Dancing is what to do. Dancing's what I think I'll do. Dancing's what clears my soul. Dancing's what makes me whole. Dancing is what to do. Dancing's what I think I'll do. Dancing's what clears my soul. Dancing's what. Dancing is what to do.
Okay, so after doing all the measurements on the engine and getting the cylinder bore diameter and then the stroke distance, we just need to find the compression ratio by calculating SV, which is the sweep volume. So that's like the up down, or I guess in this case just the up. And then I found the clearance volume, which was given to me by the machine shop. So that's these two values here added together over the CV, the clearance volume. So our ratio becomes 11.1 to 1, which in the equation that I'm going to show you on the next page gives us an R, lowercase r value of 11.1. So now we go over here. So now we have our Otto efficiency, which is the max thermal efficiency that we can get out of this engine. So our compression ratio is here. That's where the 11.1 is going to go. And I'm going to use the specific heat of air to calculate the efficiency. So we compute that, we get 0.618, which is 61.8% efficient. So I did a little diagram here, which is 100% efficiency, which we'll never get, our Carnot efficiency, which I calculated down here. And so what I did for the Carnot efficiency was I used a temperature of -30, which is like what it would be, the outside temperature, the lowest temperature possible. I would say that the car could be in outside, that we would turn it on and run it. So I put -30 degrees Celsius, which is 243 Kelvin. And then for the hottest possible one, since it's theoretical, this is the theoretical maximum efficiency, I put just below, so like 0.3 below actually, the temperature, the melting point of aluminum, which is what the block is made of. And that's the material with the lowest melting point. So everything else in the engine is steel, and so it would melt after. So this is the first thing that would melt due to too much heat. So 660 degrees Celsius. When we do the Carnot efficiency calculation, we get 73.9% efficient, the engine. And so when we compare the two, it does check out if we use these parameters, because 73.9% is the maximum theoretical efficiency of that engine, meaning we could get maybe closer-ish, and maybe if we did more optimizing and things like that, we could get this number a little bit closer, but this is already pretty close to, to efficient. I believe the typical kind of like gas engine everyday car is between 35 and 40% efficient, like their real efficiency. And so in this case, with the car that we're doing all these measurements on, I don't have enough data, I would say, to be able to find the real thermal efficiency. But just a little bit of specs about the car is that the horsepower, or we could say the work done by the engine, the output at the crankshaft is 895.2 kilojoules, which is, quite a bit. 1200 horsepower is a lot for a Honda Civic engine, so that's quite a bit. And then this is where I'm missing most of the data. So all I could say is that the temperature at detonation in the engine is approximately 2,500 degrees Celsius. So I'm sure I could figure out or take more maybe measurements on the car to get, like when it's up and running, because obviously it's not running, it's in pieces, to get a Q input to find the real thermal efficiency of the car. But for now, all we've got is the Carnot percent efficiency, the Otto cycle percent efficiency, and then the real would be anywhere below 61.8%.